In this video, we're going to talk about wave reflection and wave superposition. And so the only real thing I want you to remember about reflection is that if we have a wave, you can think of this as a slinky or a string or something, and that wave hits a fixed end. So I'm drawing that as like a wall or something. And we have our wave and it's going to the right. Once it actually hits the wall, it's going to reflect back, but when it does, it's going to be inverted. So here we have it, we'll call this right side up, and then it comes back upside down. And the reason for that is that when this wave hits the wall here, it is applying an upward force on the wall. But the wall doesn't move. But remember from Newton's third law that the wall will apply a downward force, equal and opposite force, right? And although the wall doesn't move, when it exerts that downward force on the slinky will move. The slinky will kind of pop down as it reflects and go back the other way. And that's just something to be mindful of. And I think that you guys saw this during the lab, that the wave will reflect and come back on the other side. So wave superposition is really about adding waves together. So if you have two waves in the same medium, it wouldn't really make sense if both waves were there simultaneously and you could see that as two different waves in one medium. And for instance, if we have two waves like this wave and this wave, we'll call it 1 and 2, in the same medium at the same time, they combine to make one net wave, and that could be wave 3. And I say net because what happens is these smaller waves that make up the bigger wave can be added together. And so see that the amplitude represents the displacement, right? It's the displacement of the medium. And so if you have displacement from one wave is this much and displacement from the other wave is this much, it makes a net displacement of this much. And you can see that in this half over here, these two waves, waves 1 and 2, are in phase. And that just means that the peaks are lined up with the peaks and the troughs are lined up with the troughs. And so what that gives you is constructive interference. And constructive interference just means that when the waves are lined up, so they're in phase, when the peaks are lined up with the peaks, it'll make one really big peak. And when the troughs are lined up with the troughs, it'll make one really big trough. And you'll see that these two waves combine, they kind of add together to make one larger wave. Here we have destructive interference. You'll see that the peaks are lined up with the troughs, so they are out of phase. Trough and peak, peak and trough. And you see that so this amplitude here, say it's a positive 1, will perfectly cancel with this amplitude here, which is -1. And you end up getting no wave at all. That's destructive interference. And kind of everything in between can also happen. So these two are really kind of easy examples. But if we look at something like this, and this applet lets us look at that net wave, right? And this is called wave superposition. Another way of saying it is that these two waves will interfere and make one net wave. You'll see that this box here shows us the resulting wave, and we can change the two waves that kind of make it up here. And so right here you'll see that at this first part here, at this kind of 0 point, the amplitude is 0. And that's because I've now lined up this trough, -1, with this peak, 1. So at this point, there's 0. And you can see that when you add these together, they make this kind of weird looking shape here. And I can kind of change how that shape looks just by changing the waves. And again, each point in here is just literally you're adding the amplitude of like this here and this here, and that gives you that amplitude. And we can make all sorts of funky shapes, and you guys can play with this and make sure you understand that. And that's called wave superposition or interference.